Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey everyone, before we get going with today's episode, I just want to let everybody know that I'm working on getting together Mike and Pedro's EPROM and programming class here in the Twin Cities, Minnesota area. This would be the first weekend in June 3rd and 4th. This is a 2-day hands-on class where you get to use the tools, solder to the boards, change out EPROM chips. I've personally taken this class. It's fantastic. You learn a ton. You get to use the tools that you might be considering purchasing before you purchase them, and learn an enormous amount of stuff about what's going on inside of the computer and how we can profit from that as well by fixing, cloning, repairing some of these dead modules. So if you want to know more details on this class, check out episode 71 of this podcast. I had Mike and Pedro come on and explain exactly what it is, but you could probably talk to anybody who's taking it, and they always have great things to say. It was one of the most talked about classes at Vision Kansas City just recently. So if you're interested in coming to this class, first weekend of June 2022, that would be the 3rd and the 4th of June in the Twin Cities, Minnesota, reach out to me either through email or Facebook, and I'll get you on the list. All right, with that out of the way, let's jump into the episode. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and you are stuck with just me today. No guest on the show this week. Instead, I'm going to go through a couple case studies that I've had recently, doing some mobile diagnostic work. Both of these I found pretty interesting, and there were some points that I wanted to bring up with both case studies. So the first one that I'm going to go through is a 2014 Infiniti QX60 Hybrid. So this is an Infiniti SUV, similar to the Pathfinder SUV. It's got a 2.5 liter 4-cylinder engine, along with the electric assist motor and high voltage system. So it is a hybrid, CVT transmission on this one. That's, besides the hybrid component to it, very similar to the CVT transmissions found in a lot of other Nissans. And on that note, the reason I was called in to look at this vehicle was to program the TCM after CVT replacement. Okay, so this is a transmission shop. They replace the entire CVT, which is usually what I find is done with these. I don't know of any shops that actually rebuild the transmissions in these things. They buy new units and put them in. Obviously, a ton of problems with these CVTs and Nissans, and that's not exactly what this is about. But I was called in to do the programming after the fact. And what I'll do here is actually walk you through the steps on what's needed after a CVT replacement. I won't spend a ton of time on it, but I do want to highlight what needs to be done after you do this. So if you're looking at replacing one of these in your shop, you'll know the requirements after the fact. And if you don't have the equipment, you can call somebody in to finish the job up after the physical component replacement. So per service information, there are 4 different steps that you need to do after CVT replacement on one of these. The 4th step pertains to a hybrid only system, which this one is. But the first one, and you could probably do these out of order and it's not the end of the world, but the first one that I do is I check to see if there is an update for the software in the TCM. Now, the TCM in this application is external to the transmission, meaning that if you replace the transmission, you're not changing the transmission control module. That's staying original to the vehicle. And there are Nissans where that's not the case, or vehicles where that's not the case, where if you replace the transmission, you're also replacing the transmission control module. One example would be like a Nissan Xterra. The valve body is the transmission control module. So if you replace the transmission, you're changing the module, and that's going to require programming. In this case, all we're doing is checking for an update to the software in the TCM. Reason being is, like I mentioned, they had a ton of problems with these CVT transmissions in these things, and Nissan did release a software update that you can push into the TCM to improve shift quality and life of the transmission. Maybe. I don't know. I still see a lot of problems with these, even with updated softwares. But I do check for that when I'm called in to do this. Now, you wouldn't absolutely 100% need to do this in order to drive the car, but if you're getting paid for a service, changing out transmission, highly recommended that you do this. Plus, Nissan has a service bulletin outlining that they recommend you do this on replacement to extend the life of the transmission. So in order to do this, to see if it does need a software update, what you're going to do is go in to the TCM with the scan tool, go to ECU info, should be one of the first screens once you get into the transmission control module, and it's going to pull up a software number, or I guess you could look at it as a part number, but a software number that has two sections to it. So there'll be 5 digits, a dash, and another 5 digits. And what you want to do with these numbers is jot that down or take a picture, and you're going to go to nissanTechInfo.com. And there's a couple different sections depending if you're using Consult or NERS, but you're going to go into the ECU reprogramming info section, and it will have a field where you can enter the part number, the two different sections, and it will pull up if there's any software updates to the one currently installed in your vehicle. Okay, so you go to the reprogramming section, and keep in mind there's a section on that website for reprogramming software, so that would be an updated software. There's already a programmed module in there, like the one I'm dealing with, but Nissan offers an update to said software. And then there's also blank software. So this would be a brand new module that never had any software in it. And you do want to pay attention to which tab you're using, because it will change what's looked up for you. So in this case, there's already software in there. I'm looking for the updated software. I'm going to punch my numbers into these fields and see if anything comes up. Now, in this case, nothing came up, which means I had the most updated software in this transmission. And so I don't need to actually do a reprogramming event as far as updating the software in this application. But I always check for that when a transmission is replaced, and sometimes it needs to be done, other times it doesn't. If it does need it, you can purchase the file from Nissan's website for $20 or something, $25, download the software, and then it's a whole process. Depending on the system that you're using, NERS, which is the J2534 version, or Consult, which is the factory Nissan version. There's quite a bit that actually goes into that. I'm not going to outline that here. If you're interested in that, Keith Perkins has some great videos on how to do Nissan programming. Check that out at L1Diagnostics.com, and he goes through the entire process for you. So if you're interested in that, that's what I would recommend doing as far as learning Nissan programming. But I didn't have to do that here, so we'll move on past that step. The next step is that the new transmission should come with a CD. And this is a white CD with a QR code stamped on the top of it. And what is on this CD is the calibration information for the exact transmission that's being put into the vehicle. Now, you need to put this calibration information into the TCM. The TCM has the calibration information from the old transmission, which is obviously different than the new one that's being installed. And without this information being put in, the shifting and the feel of the transmission, and even the life of the transmission, can be affected if it's not updated. And I've seen where people just throw a transmission in, they don't change anything. It's important to update this information if you're putting a new or even a used transmission in one of these Nissans or Infinitis. This is an Infiniti. I keep saying Nissan. Same thing to me. Anyways, there's a number of different ways that you can actually get this calibration information into the TCM. So number one, you can use the CD that comes with a new transmission use a CD drive, use Consult, and that's the factory Nissan programming interface, and actually push it into the module that way. That's one way that you can do it, and the way that I've done it in the past. You can also use the QR code that is both on the CD itself, right on the front of the CD, or there is also a sticker on the range sensor on top of the transmission that will have the QR code as well. And within that QR code is the calibration information for that transmission. So the Autel will actually take a picture of this QR code, decode it, and punch the information in to the module. And I've actually found that's the quicker way to do it than using a CD drive. The Autel moves through the process fairly quickly and is pretty good at it. Now, you can also decode this information with an iPhone and punch it in manually. That's probably going to take you a little bit more time. So I would definitely use the Autel's camera ability. I think there's other scan tools, aftermarket scan tools, that have this capability as well. I haven't tried them myself, but I have used the Autel, and I do know that works for this. So if you don't have the factory software, the Consult, you can still do this portion. Programming is going to be another thing. You'll need a JBox or a Consult to do the software that I mentioned earlier. But for the calibration information, the Autel is fully capable of doing this. And it's pretty quick too. I like going that way as opposed to using the Consult, although both of them work just fine. So in this case, again, I have a CD. If it was a used transmission, which, I mean, I don't recommend doing that on one of these, but places do, you're going to need that number off of the top of the range sensor. Now, if that tag's missing, there is a link through the Nissan website where you can actually download the calibration information using the serial number that's stamped on the top of the transmission, and you can purchase the calibration information. I've never tried this myself, but that is an option that they outline in case you don't have a sticker, you don't have a CD. You can use, I think it's a 7-digit serial number on top of the transmission stamped onto the actual bell housing, and punch it into the Nissan website and download the calibration information. Again, never tried it personally, but I did see the link there. So that's one more option to get the calibration information in there. The third step, which if you're doing this with Consult or you're doing it with Autel, it's actually built into the process, is to clear the learned data, or the learned adaptive data, out of the TCM. And you can do this separately, but like I said, if you update the calibration information through the Autel or the Consult, it has you do this as part of the process. So you really can't avoid it. And what it has you do is cycle the key a couple times and put the shifter into reverse and depress the accelerator pedal. And in some Nissans, it has you clear codes out during this. Other Nissans, the tool will just erase the data itself, and it's just clearing all the adaptive memory out of the TCM. And then again, within that process, it will enter the actual calibration information for the transmission. And then after driving the vehicle, the adaptive data will update as well. So a number of different things that are going on there. Software updates potentially, calibration information for the specific transmission, and then clearing the adaptive data within the TCM. So on normal CVTs, that's all you need to do after replacement. Obviously, test drive, check codes, that sort of thing. On the hybrid version, which are less common, but again, the Pathfinder has a hybrid version, and this Infiniti obviously does as well. The fourth thing that you need to do after transmission replacement is to do the resolver offset. And then this is going to be a function within the traction control motor ECU, which is running the actual hybrid electric motor portion. So it's a special function. It's a very quick, you hit a couple buttons, it learns the resolver offset, which from my reading is the sensor assembly for the high voltage motor that operates the vehicle, or, propels the vehicle. I could be a little bit off on that. I'm not the all-knowing expert on hybrid components, but from what I could gather, that's what it was. Either way, it was very simple. I performed that. So we do the calibration information, reset the adaptive data, do the resolver offset, clear codes, and I should be good to go, right? Well, okay. So none of this has been incredibly interesting so far, but after the fact, that I do this. I go to start up the engine, or at least get into a ready mode, right? It's a hybrid vehicle, so maybe the engine doesn't actually start, but it should go into a ready mode where I can move the vehicle back and forth, whether the engine's running or not. And I go to press the brake pedal, and this is a push button start, so I press the push button, and it pops up a message on the dash showing a picture of pressing the brake pedal and pushing the push button start, which I am doing, but it keeps telling me to do that. I can let go of the push button, press it again. It pops up with that message again. And make sure that I'm pressing on the brake hard enough and everything. Cycle the key a few times, and the dash is lighting up. It's not like it doesn't recognize a key. It doesn't say anything about key missing or improper key. I could hold it up to the button, which is the fail-safe in case the battery in the key dies, the proximity key. That doesn't make a difference. It seems to be recognizing the key, but it's not going into a ready state. It's not cranking the engine. It's actually acting like either I'm not pressing the pedal or there's something wrong with the brake pedal input. Okay, so the reason why I thought this was odd was because I actually did start the vehicle when I first got there. I hopped in, had the key, pressed the brake pedal, pressed the start button. I heard it run. I actually heard the engine start up and run when I first got there. So immediately I'm thinking, okay, well, what did I do here to cause this problem? Because I'm not an expert on hybrid vehicles. This particular vehicle is the first one I've worked on that is a hybrid in a Nissan or Infiniti. So I'm like, well, what step did I do wrong? And I was thinking, well, I did use the Autel to punch in the calibration information for the transmission. Maybe that messed something up. So I decided, okay, let's go through, check codes and see, did anything set here? Maybe I missed a step. Maybe I didn't read service information for this particular application. I don't know yet, but let's dig into it and see, just make sure it's not something that I caused, because I'm kind of thinking it is since it started when I first got there. So I did have one code in there that at least seemed to pertain to the system that I was dealing with, and it was a B2604 in the BCM that said PNP clutch switch, or PNP/clutch switch. And from what I could tell on this, that it was park neutral position / clutch switch if it was a manual, which it's not. The code kind of doubles for both systems, but in this case, it's an automatic transmission. And it's saying that the BCM is experiencing a disagreement in the park or neutral position based off of the shifter and what the TCM is saying. Okay, and this code actually was stored in the BCM, meaning it was a history code. It didn't say current. And so I just tried clearing that code out to see if it made a difference, and it didn't. And it didn't pop up right away. It didn't come back, but it still wouldn't start. Again, I'm on the brake pedal, I'm hitting the ignition switch, and nothing's happening. So I go into the scanner, and I'm going to keep that code in mind, but I'm looking at the data PIDs for both the ignition switch and the brake pedal in all the modules that I feel are relevant to starting the engine, right? Let's look at the BCM, see what it sees for park neutral position. Let's look at the input from the brake pedal. Let's look at the input from the ignition switch, and everything seems to be where it should be, right? It recognizes that it's in park. I move the shifter around and it recognized movement from the data PIDs that I could see. Now, do keep in mind, Nissan Infiniti data PIDs are weak at best, at least in my opinion. The acronyms you have to look up to see what a lot of them mean, and the scan tool data is just limited in general, I feel. But everything that I could find for what's needed to crank the engine, I felt like I did have. I didn't see anything that's out of order. And I may have missed something. I may have missed a data PID that was important, but I'm going to do a little bit more research on this one code that I had and just the situation that I'm in, just to see if I missed anything. And this is one of the points I wanted to make about this particular vehicle, and a lot of others, of course, is really paying attention and utilizing service information, because it can help you out of a bind and get you to a solution faster than it would be if it's just you trying to figure this stuff out. So I actually just punched this code in to Identifix to see what did this have to do with the components that I was servicing. Again, I kind of want to see, is this something that I caused, or is this something else that happened with this vehicle, on replacement of this transmission? And
it's just a coincidence that it started for me the first time and not the second. But before I go into the shop and talk to him, I just want to verify that this is not related to something that I did. So there's actually a service bulletin for this B2604 in this vehicle. And it even says it's for a no crank condition. And what they have you do in the case of this code, and it even says this code could be current or it could be history, to check the adjustment of the shift control cable. So that would be the cable that goes to the transmission and connects to the manual lever that goes into the transmission and changes from park, reverse, neutral, drive, low, right? And that's the physical cable connected to the shifter in the vehicle. And it wants you to check the adjustment of this cable. And the way that you adjust this cable is you loosen the nut that's connected to the threaded portion of the actual shift cable that tightens down to the actual manual lever. And the manual lever has a slot in it. So you could actually move the shift lever about an inch back and forth and then tighten that nut down. Now, of course, they changed the transmission. And so they definitely had this off in order to change the transmission. So there is a possibility this could be out of adjustment. And that's what the service bulletin is outlining. And it has you walk through a procedure to do this. And of course, I went into the shop before I touched this and I said, hey, this is what I'm experiencing. Do you want me to do this adjustment? I'm going to charge you extra for that. And they were fine with it. They were like, yeah, just, let's get this thing going. We don't care. We just want to make sure that it's good before you go. Right. And I want to do the same thing. I don't want to leave them with a vehicle that's not starting when, again, I have a feeling that this was because of the replacement of the transmission, but I want to make sure that this takes care of it and it's not something that I induced into the vehicle. So I pull the air cleaner assembly off and I could get to this thing pretty easily. I follow the procedure. It has you clear the codes out of the system, which I did. Has you put the vehicle into park, then into drive, and then back into park. So you're moving the shifter backwards and forwards. And then it has you push the vehicle slightly to make sure that the parking prawl has engaged in the transmission. So you want to hear it kind of click into place and make sure that the vehicle doesn't move. Okay. As you set the parking brake for safety, key off the vehicle, and then you're going to go out to the transmission. You're going to loosen the nut on the shift cable, verify that the manual valve is in park, and you can move this by hand or take a wrench or take a pliers and move it, but verify that it's in park, verify that the shifter's in park, and then tighten down the nut again while holding the manual lever, which is exactly what I did. Now, I could see where the nut was before. It had left a little indent in the manual lever, and I was not too far off from where it was originally. I mean, maybe 4 millimeters or so. I mean, that's probably even exaggerating a little bit. I didn't think it was very different from the position that it was at. Very, very small amount. So I didn't know if this was going to take care of it or not, but it was in a slightly different position than when I started. And so turned on the vehicle, went to hit the start button, and it actually did fire up after this. And I tried it several times, let it sit for a while, tried it again. Everything seemed to be okay. Didn't have the code setting in the BCM like I had before. So there must have been some sort of misadjustment between inside of the transmission and the BCM. I don't think I caught it on the data PIDs, and maybe I didn't know what data PIDs to look at exactly. But either way, the service bulletin just led me right to what I needed to do. And again, I charged a little bit extra for this, for actually doing that adjustment on top of the update of information to the transmission. So after that, again, just check for codes, and I collected my money and I was done with that one. Or at least I thought. There was a little bit more to this one, which is why I want to talk about this vehicle. So I get a call the next day, or actually it was a text from this shop, and he sends me a picture of the dashboard. There's a couple lights on. There's a check engine light, and there's a little picture of a vehicle with an arrow pointing down. I think it was a reduced power light. And he says, hey, there's lights on after you programmed it, and there's a noise from the rear end. And when I see this text, I initially think, I'm kind of on the defensive right away, like, what is this guy saying? Because he didn't come out and say, you caused this, but he said, the vehicle that you programmed, now the lights are on, it's making noise in the rear end. Well, I know that noise in the rear end is not going to be caused from programming. And who knows, maybe the lights are caused from something I did, but I do a lot of the CVTs in these Nissans, Infinitis, and I've never had an issue doing what I did. Of course, the manual valve adjustment, that's beyond what I'm normally doing in these, but I had a couple options. I can be on the defensive and I could text back, yeah, I don't think any of that's caused by what I did. Or instead of assuming that he's accusing me of something, I can just question him, which is what I decided to do. And I found this is the best way to go. Rather than going immediately on the defensive, just ask more questions and you'll get more information out of the customer and avoid some conflicts, which, hey, sometimes a conflict is necessary, but not always. So I just asked him a question. I said, well, did you guys drive it before to see if the noise was there? And he actually did say, he's like, well, yeah, the noise was there before. Okay, well, I don't know why you didn't mention that in the first place, but he did say that. And I was like, well, do you want me to come diagnose the check engine light? That's what I said. And again, it's kind of working that way towards, does he assume that I caused this, or does he just want this stuff solved? Well, as it turned out, and this is a good shop, they just wanted it figured out, and he was willing to pay me to come back and do this for both the rear end and for the check engine light. Okay, cool. I'll do that. So end up going back. I scan this thing to see what's going on in it. And I have codes in the hybrid powertrain control module. So this is a control module that's in charge of the hybrid drive system on this thing. P3179 and a P317B. I'm not familiar with these codes, so I have to look these up. And when I do look up these two codes, basically what these mean is that the HPCM, or hybrid powertrain control module, has recognized that there are codes in another module, specifically the traction motor inverter module. So, and in the scan tool, this is called motor control. So, we see this a lot in a lot of different modules where you'll have codes that set in a particular module, and the only thing that those codes mean is that there's codes in another module. Again, one of the important reasons to do an all system DTC scan. Okay. But those are the codes that I saw first, and it had me go to the motor control, or the traction motor inverter. So I go into that control module, and I'm not sure why they separated, two different modules for this thing, but that's, we're finding, multiple control modules for systems on vehicles now. And in the traction motor inverter, there's a P0A01. This code says motor electric coolant temp sensor range performance. And if you look at the definition, it says the difference in value of the coolant temp and inverter temp. Specifically, that 203 Fahrenheit is the limit of the inverter. Really what that's saying is that the temperature of the coolant is different than the temperature of the inverter itself. So the inverter is one of the high voltage electric components that's going to be in charge of actually handling the high amount of voltage that's going to the motor to move the electric motor to move the vehicle. So it's handling a lot of current, and therefore heat has to be removed. So we see a lot of times on these hybrid systems that we have two cooling systems, one for the internal combustion motor and one for the high voltage electronics. That's been a thing for a long time in almost every hybrid vehicle application. So you can have two cooling systems, two reservoirs, two coolant caps that need to be serviced separately. And sometimes, they'll share a radiator, but still be two separate systems from one another. And again, this code is stating that the coolant temp and the inverter temp are way off from each other, and that the inverter is overheating. And I did verify this. You can clear this code, go out and drive it, and that inverter gets hot pretty quickly. You make it down the block, sets the code again. So my inverter is getting really hot. Again, coolant temp staying fairly normal. So let's inspect the cooling system. They had the transmission out of this thing. It's very possible that the cooling system is just low on that side. I would assume they would have checked it, but let's pop the hood and find out. So the coolant reservoir for this hybrid system is actually on top of the valve cover. It's under its own plastic cover, so you can't see it until you remove this plastic cover, but it's sitting right on top of the valve cover of the internal combustion engine. And it's just your regular coolant reservoir, just clear plastic with a pressure cap on the top of it and a couple hoses going to it. I could see the coolant level in there. It's like a bluish green tinted coolant, and it was about halfway up the reservoir. And I was like, well, there is coolant in there. And I open the cap and I look at it. Now, even though the reservoir was about half full, if you look at how the reservoir is assembled, there's a big hose that goes into the reservoir, but it's about 3/4 of the way up from the bottom. And the coolant level was actually below this hose. And this big hose goes down to the front side of the engine compartment near the inverter and electric water pump. And so I was like, well, the coolant level should probably be at least up to the level of this hose. So I run in the shop, I ask them for some coolant, I fill it up, it comes up to a level pretty quickly. I barely added anything. So the other thing that I wanted to do here is make sure, well, there's not any air pockets in here or anything like that. So I was actually able to take, and the Topdon did work for this, I was able to take the scan tool, go into the special functions, run the electric water pump for the high voltage cooling system, and it started to run. I heard it like gurgle and spit, and a bunch of bubbles came out from the reservoir. It ran for maybe 2-3 minutes before it stopped spitting out air bubbles. I had to add more coolant as it was going. Finally got it to the point where I could hear the pump running, but I wasn't getting any more air bubbles out of it. I put the cap on, I cleared all the codes from the system. I went out and drove this thing, and it wasn't overheating anymore. So this was just as simple as the coolant level was low in this thing, causing it to overheat. The inverter set this code, turn on the check engine light, reduced power, all of that stuff. So they just forgot or didn't realize that the cooling system was not full on the high voltage side of the system. And again, if you just took a quick look at that reservoir and it was about halfway full, you might say, okay, that's good. But this system was actually pretty low on coolant because of the way that reservoir is constructed. And I actually didn't see like a fill line on there unless it was on the backside. But once I got it to the point where it was pulling coolant in through that hose, it was good to go. So the final thing on this one, they wanted me to look at the rear end. I went out and drove this thing. I was driving it after the cooling system fill. I took it on some sharp turns on dry pavement, and I could hear it just like chattering or vibrating from the rear end. It was making a little bit of a noise, but you could feel it in the body of the vehicle. You can kind of feel it in the steering wheel. And what it felt like to me was just that the rear end was just binding up. If you imagine a 4-wheel drive vehicle trying to turn it on dry pavement, or if you've ever worked on a vehicle that had limited slip, that needed the friction modifier changed out in the fluid, you get that kind of chattering around corners and stuff. That was the same thing that was going on there. And so again, I just did a simple search for these sort of symptoms on this vehicle. And there was, again, a service bulletin on this vehicle that pointed me exactly what to do. It's the electric controlled coupling unit on the rear differential. And so this is just like electro-viscous clutch that's on the rear end, controlled by a drivetrain control module. It's just got 2 wires, power and ground to it. The TSB has you unplug it, go out, drive it. If it removes the symptom, then it says to replace this unit on the back. So I did just that, needed that to be replaced. It went away once I unplugged it. Okay, cool. Service bulletin outlined exactly what I needed to do. So that was another really, really simple one. So some of the point of this one was service information was so helpful through all of this. The procedure on what to do after transmission replacement outlines it exactly. Of course, I had done this before, so I was aware of that. But the service bulletin that was used for the no crank condition and exactly what to do got me the answer that I needed. I used service information for some of those hybrid codes that I was not familiar with and pointed me exactly to where I needed to go. And the service bulletin for the rear end chattering noise just got me to the solution much faster than it would have been if it was just me and I didn't have any. So of course, most of us are aware of this, but don't forget, you're going throughout your day and you're just moving along. Maybe it's something you're familiar with. Maybe it's something you're not so familiar with. Always take the time to reference the service information. Punch those codes in, look up system description operation, glance through the service bulletins. A lot of the time, this can get you to that solution faster. So that was my Infiniti, the number of different issues that we worked through. But it did end up being pretty profitable for me. I got paid for the programming for the transmission. I got paid to adjust the shift cable. I got paid to diagnose and bleed out the high voltage cooling system, and I got paid to diagnose the rear end. So although it was, a little bit of work to get through all that stuff, it was a good ticket. So on to the next one. This one was interesting. We see a lot of these vehicles, and maybe some of you have dealt with problems like this before, but there was a couple things here that were really important. The process that's used to get to a solution on a diagnostic problem, specifically this one, a drivability problem, but also the importance of asking questions from the customer, or in my case, the shop, who is my customer. But, if it's the owner of the vehicle, it's just as important to ask questions and get as much information as possible. We really got to interrogate these people sometimes. And in this case, I did ask questions, didn't ask enough, should have interrogated a little bit more than I did. But either way, this was just an interesting problem, and I want to walk you through how I got to the solution. So the vehicle, 2011 GMC 2500 Sierra, has the 6.0. This vehicle, the shop told me that it was purchased from an auction. Now, the shop itself actually purchased this vehicle. They do some buying and flipping of vehicles from the auction here and there. And after they purchased this thing, the owner of the shop said he started and drove this truck, and that it started okay and it ran okay. So initially, he didn't assume there was any issues with this truck. They parked it in their back lot. They were going to go through it and check everything, and they never got around to this vehicle for almost a calendar year. So it just sat there for about a year in the back lot. And during that time, sitting in the back lot, somebody went and they actually cut out the catalytic converters out of this truck. It seems to be happening a lot around here. I don't know if it's the same in your area, but I seem to run into vehicles all the time where the converters are stolen. So not uncommon. And they found that out eventually, that the cats have been taken out of this, at which point they got some new cats for it. And they also replaced all 4 O2 sensors. And I'm not sure, where they cut it exactly, if they got the O2s with it, or if the shop just decided to put on new O2s, or they couldn't get them out of the old exhaust. I don't know. But either way, 4 new O2s and 2 new cats. After which point, this vehicle, it would start, but it would run very, very poorly. It would struggle to run. It would chug and it would stall, and there's not drivable at all at this point. And all that the shop was aware of is that they changed these cats. Now, I did ask them, I was like, did you guys do anything else to this? Because this is where they call me in, because they've been trying to figure this out. And they said, we replaced the mass airflow sensor, and we also drained the fuel tank and put some new gas in it. Okay, so that was all I was aware of at this point, was new cats, new O2s, new mass airflow sensor, and drained the fuel tank and put new gas in it. And they said the gas was old. That's all they said, is the gas was old, so they put new gas in it. Okay, so that's the information they have going into this thing, but I'll check it out and see why this thing is barely running. He did mention that it was running rich. That was the other thing. And so I want to confirm this, hook up my scan tool, check for codes. We do have 2 rich codes, both banks, for this engine, the P0172 and P0175, rich bank 1, rich bank 2. Okay, so I start this thing up. Now, here's the thing I note immediately. As soon as you start it up, this thing's running like garbage. So this is as soon as you run this thing, it is running very, very poorly, and it continues to run poorly. And actually, the longer that it ran, the worse this thing got, to the point where it's like loping and just barely struggling to idle. You can't rev this thing up. It's barely clinging to life. I was kind of surprised it was running at all, because it was just kind of just chugging really, real slow. So I want to try to get a feel for what's going on with this thing. I'm going to look at the O2s and try and see if I can even utilize the fuel trims on this thing, just to see where am I at, what's happening. Is this thing running really, really rich? Is it it the codes that I have accurate? And so I look at all four O2s, and at first, like I said, this thing was in a open loop state and running poorly there. I actually did get into a closed loop state, the point where it's utilizing fuel trims. The fuel trims were negative on both banks. And if I looked at my O2 sensors, this is the part that was a little strange. My upstream O2 sensors were both reading 1.8 volts. And these are narrow band O2s. These are not wide band. They're not air fuel ratio sensors. These are narrow band O2s reading 1.8 volts on both the driver's and the passenger side bank of the engine. That's upstream. My downstream sensors, however, were reading about 50 millivolts. Okay. So that would be 0.05 volts if you're looking at it from a voltage scale, but 50 millivolts, indicating very, very lean. Okay, now 1.8 volts, you might say, is indicating rich. To me, that indicates that something's wrong, because a narrowband O2 doesn't have the capability of creating 1.8 volts, at least not from what I've seen. So something's going on there. Somebody's lying. I have a feeling it's the upstream O2s. Now, he did say he replaced the O2s, but let's go underneath and check this out. First thing I want to look at is the heater circuits for these sensors. Now, you can actually do this through the scan tool. You can look at the amperage draw of the heaters, and it was showing about an amp for each sensor, all four sensors actually, which means there's circuit continuity, because the scan tool actually does a pretty good job of measuring that for you, how much current is actually going through the heater. And it measured correctly. I did just check with a light bulb to make sure, okay, it's lighting up. I actually started on the passenger side because the connector was very easy to get to for the upstream O2. It's right on the frame rail behind the first body mount. Anyways, power and ground of the heater is good. Okay, so let's check the signal wire to the ECM. So this would be our narrowband O2 sensor has two wires for the actual sensor portion. There's a signal wire and there's a ground for the sensor itself. I just want to make sure both of those are intact, because again, 1.8 volts doesn't seem right to me. Something's up there. Maybe we're shorted the voltage. Maybe this is an ECM issue. Maybe the sensors are bad, right? Just because they're new doesn't mean that they're good. So what I did was I looked at the voltage on the signal wire as the sensor was unplugged, right? So I unplug the O2 sensor and I'm checking on the harness side, the ECM side on the signal wire, and I actually measure 1.8 volts there. So what that means is, to me, is that 1.8 volts is coming from the ECM. And in fact, what this is, it's a bias voltage used by the ECM for the signal wire. Now, for whatever reason, the ECM had determined that this was a high voltage being output from the O2 sensor. I would think there would be some sort of default strategy that would come into play eventually, and maybe it would had I have run this thing long enough. But initially, it was reacting to the 1.8 volts that it was seeing and cutting back on fuel delivery, assuming this was rich. So I don't know the entire strategy for the ECM as far as voltage, but it was seeing 1.8 volts as a really rich condition and pulling back on fuel. But I know now that 1.8 volts should be actually pulled down from this O2 sensor if it's functioning correctly. But for some reason it's not. But I do want to verify circuit integrity to the sensor on the signal wire and also the ground side. So what I did was I took the ground wire for that sensor, which comes from the ECM. So the ECM grounds the sensor on one side, and then it has a signal wire on the other side. And I just jumped the ground wire. And this, again, this is ECM side of the harness. I jumped the ground wire for the sensor to the signal wire. And I watch on my scan tool with the key on, and I watch that 1.8 volts drop down to 0. Okay, so the ground wire coming from the PCM pulled the signal wire voltage down, and that voltage is coming from the ECM as well. Sorry if I said PCM. So I know the circuit integrity on the ground side is good, the circuit integrity on the signal wire is good, and the ECM has the capability of observing what's going on that sensor. Again, the heater's good, so this sensor needs to be replaced. Whatever they got for this thing, this sensor is not functioning correctly. So at this point, I have a feeling that there's another issue going on with this truck, because what I mentioned first was when I first started this thing up, it ran poorly immediately. And then it got worse as it started to run. And that was as it actually entered closed loop, it got worse. I have a feeling this thing is running extremely lean, but the O2s are pulling back even more fuel than is necessary, and it's running even worse. So what I told the shop, I was like, let's get some quality O2 sensors upstream, and then we'll revisit this thing, because I want to be able to utilize the O2s and the fuel trims in my diagnosis. But I told him up front, I was like, hey, there is most likely something else going on, and these upstream O2s built in another issue. So he agreed. He's like, yeah, we'll put some different ones in there and we'll give you a call as soon as that's done. So they do that. They install 2 new upstream O2s into this thing, call me up, and they say it actually does run and it runs better, but there's still definitely some issues with it. So I get back there, I check this thing out, and it starts up. It still runs poorly, but it actually does idle pretty good, significantly better than the first time that I was there. And so now I'm checking out my O2 sensors. I want to make sure everything's working correctly. The upstream O2 sensors are functioning now, and they actually agree with what the downstream O2 sensors say. And at idle, this thing is running at about a positive 25% long-term fuel trim, which would indicate a lean condition, right? The O2 sensor is seeing an excess of oxygen in the exhaust, so the computer is adding fuel in order to correct for that, but we're maxed out on those fuel trims. And if you let this thing run long enough, it sets lean codes. If you take it out and drive it, which I did, because again, it was idling okay. I wanted to see how it did at a higher RPM. As soon as you got it to somewhere between $2,000 and $3,000 loaded, this thing would just completely fall on its face. Had no power. You could hear it backfiring. There's no acceleration at all. And all 402 sensors drop out to near zero. They were talking 50 millivolts, 20 millivolts from all 402s. So all 402s are recognizing an extreme lean condition at this point. Okay, so we obviously still have an issue. It's not rich like it was saying before. It's actually the opposite, as this thing is running extremely lean, falling on its face. So we have to figure out what's causing that. My first thoughts, fuel pressure, or maybe fuel quality, and mass airflow sensor, right? The mass airflow sensor was replaced. They said they drained the tank and put some new gas in there. So those are the things I want to check right off the bat for a lean condition all the time, but definitely gets worse under load. Now I did try unplugging the mass airflow sensor, didn't make a difference. Okay, so I'm going to hook up a fuel gauge to this thing, and I did find I could duplicate this problem by power braking the vehicle. So I put it into drive or reverse, step on the brake, accelerate with the pedal, and I could get this thing to fall on its face and the O2s to drop out. So I didn't even have to drive it, which was handy because I just hooked up my fuel gauge to it. Watch the PSI, it's like 55 PSI, somewhere in that neighborhood, maybe a little bit more. Power brake this thing until it fell on its face. The fuel pressure never moved off of its mark. So at the rail, at the Schrader valve at the rail, I'm getting adequate fuel pressure, even when this thing's falling on its face. So the pump is able to supply enough fuel up to the engine. While I was there, I got my gauge hooked up. I took a fuel sample. It looked like brand new gas. Did not appear to have sediment or any issues with the fuel itself. So on the fuel delivery side of things, up to the rail, everything seems good there. I'm still questioning the mass airflow sensor, even though it didn't change when I unplugged it. I want to make sure that this thing's reading accurately because it's new. And again, mass airflow sensors, well, just electronic components in general, replacement parts like those O2s that I was talking about could be off. They could be reading incorrectly. So what I did next was a VE test. Now, this is limited because I wasn't able to achieve a very high RPM with this thing because it would just fall on its face. But I used the VE calculator at atg.com has a VE calculator. I punched the numbers in to the VE calculator as I was driving it, and it came out with some pretty good numbers. It was between 80 and 90% for the RPM that I reached. Now, would this have been different had I had a higher RPM? I don't know, but from what I could tell, punching these numbers in the VE calculator, the mass airflow sensor was reading correctly. And again, the reason I know this is the VE calculator uses grams of air per second as one of its pieces of its calculation, right? To figure out, is this engine based off of the size, the RPM, the cylinders, barometric pressure, the intake air temperature. Is it moving enough air through it based off of what's, the theoretical correct amount of air to move through that engine? And this can help you find restrictions and stuff, but it can also help you find a mass airflow sensor that's not reading correctly. And there's a lot of training information out there on this, but I use fuel trims in conjunction with the symptoms that I'm experiencing to determine, is this thing reading correctly? Now, again, because I've got a pretty high number, 80-90% of my VE test, and my fuel trims are reading in an extreme positive direction, both idle and acceleration, I know that this is not a mass airflow sensor reading incorrectly. Because if the mass airflow sensor was causing us to run as lean as it is, positive fuel trims and falling on its face, it would be reporting a number to the PCM that is much lower than what's actually going through it, and our VE calculation would be at a very low percentage, right? Now, you could get a low percentage from air restriction or a timing issue or something like that, but it's not going to throw your fuel trims off in the same way as if a mass airflow sensor is off. So when you're using a VE calculator to determine what the problem is, you've also got to incorporate those fuel trims to help you out. And I can be pretty confident from what I'm seeing here that this is not a mass airflow sensor causing this. Okay. So now I'm really down to the fuel delivery to this engine. And what I mean by that is what's being sprayed out of the injectors. I know it's not enough. I know this thing's starving for fuel, both at an idle and under acceleration. But my question here is the ECM commanding this amount of fuel, right? Are we not getting the correct amount of fuel into the engine based off of an ECM command? The ejector pulse width is not large enough or long enough? Or is there a physical restriction or a physical reason that fuel is not able to make its way through the injectors at the proper volume? Now, I already tested pressure under load, and some people say, well, you could do a fuel volume test, and that's fine and all. But honestly, me personally, I believe if you have correct pressure under a load, you don't need to do a volume test. And I've definitely had some, discussions with people on that believe that doing a fuel volume test is really critical. And there's nothing wrong with that, but I had 60 PSI or close to it under a load when this thing's falling on its face. I don't believe that this is a fuel volume problem. Now, maybe some really strange restriction in the rail, but the Schrader is on the passenger side of this rail, and the entire engine is experiencing this issue. I couldn't see how it was a rail restriction, but the other thing might be an injector restriction, right? They did say this thing was sitting for a year. They said they drained the tank. I don't know what the old gas looked like out of this thing. My next thing that I want to do is do an injector drop test, just to make sure that I don't have restricted injectors. So I do this. You can do it through the scan tool. There's a function to do injector balance test. It pulses all 8 injectors at the exact same amount, and you just prime the fuel pump between each injector, and you watch to see what the PSI drop is. You want to see them all to be even. For me, this was roughly 30 PSI for each injector, but they were all on the money. They were all exactly the same amount of drop for all 8 injectors. So either I don't have a problem with the injectors, or they're all perfectly restricted the same amount. I was like, well, that's pretty unlikely. So the other thing, again, that I was considering was, is this something that's being commanded by the ECM? Is the ECM just commanding less fuel that's needed for this engine? Possibly. Well, what could be causing this? And I'm thinking sensor inputs, coolant temp, air temp, map sensor. All of those appear to be good under load, at idle. Everything seems to be normal. I was thinking maybe calibrations in the ECM. Maybe somebody swapped an ECM out of this thing. I checked those. Those matched up to what were supposed to be in this vehicle. And I'm kind of racking my brain. And actually, this was the second time I had been back to this vehicle. I had one of my students with me from class at the college. I do ride-alongs with some of my students just so they can experience some of these issues. And he was saying, we were just sort of brainstorming in the car, looking at the data PIDs, thinking about what could be causing this lack of fuel to this engine. And he's like, did they change anything else on this vehicle? Meaning the shop. Did they change any other parts out on this vehicle? I'm like, well, he said they changed the gas, the O2s, the cats, the mass airflow. I don't think there's anything else. And he was like, well, maybe we should go just double check with them to make sure there wasn't anything else. And I was like, yeah, that's a really good idea. So I went in and I gave the guy all the information as to where I was at right now. And I was like, did you change anything else in this vehicle? He's like, well, yeah, when it was running really rich, that's what he said. And remember, with the O2s, the bad O2s, it was showing negative fuel trims and setting rich codes. He's like, we tried some new injectors. Or he didn't say new injectors. We tried some fuel injectors. I was like, oh, okay. Well, this would have been nice to know. Where'd you get those fuel injectors from? Oh, it was another 6.0 that we had laying in the shop here. I was like, okay. So now again, these injectors tested good as far as the equal drop across all 8. But now this is the first thing I need to verify is, are these the correct injectors for this vehicle? So I go out, turn the injector, because you can twist the injectors while they're mounted in the rail, and you can see the part number on the back side, or the side of the injector that faces the intake. And the part number that's in the injector is a 125-80681. That doesn't mean anything to you at the moment, but I want to see, is this the correct part number for this engine? And it's not. The correct part number for this engine is a 126-13412. Okay, so that's a completely different fuel injector. If you look at it, it's a physically looking fuel injector. So the first number, the number of the injector that is mounted into the vehicle, we did some research, we did some Googling. This is for an LY6. That's the RPO code for the engine. This was used from 07 to 2010. And it's a 6.0, right? Same size engine. That's why this thing actually mounted up and plugged in to the vehicle, but it's from an LY6 engine. The injector that's supposed to be in there is for an L96, which this engine is. That's the RPO code on this actual truck, which was used from 2010 to 17. Okay, well, is this going to be enough? Is this going to change it? They're both 6-liter engines. Aren't the injectors going to be, they plug in, they mount into the rail, they go into the intake. Shouldn't they be pretty similar? Well, a little bit more Googling, and we were able to find the flow rate for the 2 different injectors. And thankfully, these LS motors, these motors were very popular with enthusiasts. And so you can actually find the flow rate for these injectors because these motors are used in performance applications all over the place. So we were actually able to find online the flow rate. So the injectors that were in the engine have a flow rate of 30 pounds per hour at 58 PSI. That's the LY6 injectors. The L96 injectors, which needed to be in the vehicle, flow at 44 pounds per hour at 58 PSI. Okay, so that is a difference of 14 pounds per hour, a flow rate from these injectors. Of course, that's going to cause a lean condition. Okay, under the same pressure. So I found that pretty interesting that they didn't really change. They didn't change the size of the motor. It's not consuming more fuel, but they do change the flow rate of the injectors pretty significantly. So anyways, I told the shop, I was like, just get the right injectors for this thing. And, or if you still have the ones that you took out of here, they'll probably be just fine. So he did that, and then it fired up. It ran beautifully. The truck had no problems. And so the series of events here that I think happened was the cats were cut out. This thing probably did run pretty good when he first got it. Cats were cut out, put in the new assembly. The replacement O2s caused this thing to run like garbage because they're spitting out 1.8 volts, causing it to pull back on fuel when it didn't need to. The shop overcorrected for that by putting in, mass airflow sensor and fuel injectors. That's what really caused the problem. And then it got to me. We changed those O2s. We still have a lean condition. Then we changed the injectors to the correct ones, got it back to a normal running state. This case study highlights how important it is to really interrogate the customer, the owner of the vehicle, the shop you're doing work for. Get all of the information that you can. It makes your job a lot easier. Had I known the injectors were replaced earlier on, I would have been through that a lot quicker. It's going to be something I'm going to look at now on one of these if I'm dealing with a lean condition. It's a question I'll ask. I know that, you can find the injector information pretty easily on these things. The part number is right on the back. Use repairlinkshop.com. You can check to see what the actual injector part number is supposed to be. And on these particular GM trucks, you can even find the flow rate of the injector. So pretty interesting stuff. But that's all I got for you today. Thank you for listening. Really appreciate it. Let's all get out there, start fixing the world one car at a time.